Hey everyone, thank you so much for watching the Weaviate Podcast. I'm super excited to do two things we've never done on the Weaviate Podcast before. Firstly, we're welcoming both Weaviate co-founders, Bob Van Light and Etienne Dilocker. And because we just need to bring everyone in on this, because our guest is someone who has dominated the vector database market. And so I'm so excited to welcome John Dagdelen. John, can you tell us about HyperDB and how you just figured this all out so quickly?
Sure. Yeah. So HyperDB, it's a hyper-fast local vector database. We call ourselves a BS database, as in a better search database. I'm happy to tell you more if you got some questions for me.
It's just you were so fast, John. So tell us a little bit about, like, if you say, for example, is that like your whole team, or is it like a royal we? What are we? If you say we, what are we talking about? Because you're moving so fast.
Yeah, we're a worldwide community of developers. It started with me, but as soon as I put the project online, we got PRs and contributions from all over. Now we're a diverse team. We got a great Discord. We call it the HyperDB. So yeah.
Interesting. Yeah, go ahead.
Have you been able to raise money so far yet?
We have a lot of interest from VCs. They've reached out, especially after the initial announcement. We've actually raised $600 million. So, yeah.
Wow, congratulations. And why? Because it's like a trend while raising money as a vector DB to have your logo on the NASDAQ thingy. Why have you decided to stay silent and not do that?
Well, we're also stealth, even though we have a lot of PR.
Okay. That's very, very smart. Yeah, that is very interesting.
Yeah. I was really inspired. I saw a lot of companies, putting their logos out and raising money from VCs. And, I looked into this approximate nearest neighbor database thing. And I thought to myself, well, I can approximately make a nearest neighbor database. And so that was where the idea for HyperDB was born. We're the fastest vector database in many ways. We're the fastest to 1,000 GitHub stars. We're the fastest pip install, and we had the fastest external contributor join.
Wow. But I think you're even still downplaying a little bit, because I'm very curious to hear what you've been creating and people can see it on GitHub, right? It all comes together in this nice file, the Galaxy Math brainshit.py. Can you maybe share what brought you to this insight in creating this?
Yeah, I like to name files so that if you just read them, you know what they are. And we really believe that that's the key to HyperDB's success. We do things like hardware accelerated math kernel blasts. So very fast cosine similarity. And then also we have some really interesting things. So alignment is this problem that is now really, really trendy in AI that you've probably heard of. So actually, we're also an aligned vector database, and we try to be metaphysically aligned with the nature of reality. And so if you look at the Derridean similarity metric, you can see it brings in some of the metaphysical randomness that is actually inherent to life.
I can really hear the BS, the better search, and all of this. It's so great.
Yeah.
It is unbelievable. It's fantastic. Congratulations. It's just, I remember we saw it and we were like, whoa, this is just, sometimes you just have to, you see something happening and you just have to say,
Thank you so much. And that especially means a lot coming from you, Bob.
Yeah. Thank you for saying. I think it would be interesting to learn a little bit more about you, John, and what you're doing and what you're actually working on. So it's like because a lot is happening in the space, and I think what you've done is you did it exactly at the right time, and it was the right thing to do. And it is always good to keep everybody on their toes in this way. So we just, we really appreciated that, but we would love to learn more about the actual job and the actual thing that you're working on. So maybe you could share a little bit.
Yeah. So for anyone listening that hasn't caught on to the joke yet, HyperDB was kind of just a joke that I put out on Twitter. There is a real GitHub repo. It does actually work for everything it says it does. But I'd noticed, so I've been working in natural language processing, language technologies for 5-6 years now. I'm just finishing my PhD at UC Berkeley in the material science department, but I do scientific natural language processing. So things like extracting data out of research papers and training language models to help us work on, like, figure out what we should work on next. And I've been using hybrid search, vector database kind of stuff for a few years now. And then I just exploded all over Twitter. People were raising money all over the place, and it became kind of especially poignant because of the language models, using them as for retrieval augmented generation. And I think it got a little out of hand in some ways, especially just kind of the hype tweets all the time. So I thought, why don't I make my own? So on a Saturday night, I kind of was just a little, I don't know, on a whim, I built this repo, and I used I generated a logo that I thought looked kind of hyper, and then I put it out on Twitter, and then it went viral. I didn't expect it to go like this big. It got seen by 500,000 people. It hit the top spot on Hacker News. I had dozens, like, I'm not kidding, dozens of VCs reaching out to me, very big name VCs. So it was kind of funny. And they would say things like, "Hey, we checked out your project. We think it's really cool. We'd love to meet you." And it was just kind of, I got a feeling, or I got a view into what the world must be like for some of these companies that have a lot of hype going on right now.
Yeah. No, that's interesting. And I think what's so interesting about what you're saying is the so what's interesting today, I put something on Twitter. There was like, I saw this nice, and I forgot which repo it was on, but we can add that to the show notes here. You saw this nice tree, right? So where how these models evolved, and at the bottom of this tree you see like GLav, FastX, and those kind of things. Mm-hmm. And I remember that for me at least, that seed was planted, like, hey, wait a second, you can actually do something. We can do something with these embeddings when it comes to search and those kind of things. I remember that that might actually be funny to share. So the very, 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 very first prototype that I built for Weaviate was actually also in Python. And basically what I did was that I had a few of these paragraphs, and I took these individual words from the paragraphs, and then I just calculated centroids based on the words that I got from that file that was like that you could download from the GLav repo. That was actually built very fast, and it was interesting, right? But then the kudos to actually building a database and architecturing a database and what it means to build a database, I think that 100% goes to Etienne. But that insight in like, hey, wait a second, the vectors can be used for better indexing and better searching. We believe that's an opportunity for a new database in the market. But I'm curious to hear from you, John. It's like, what do you think happened in the I mean, it's easy to say, for example, in November we got like the whole ChatGPT thing and that accelerated. That is true, but I'm just curious what you think was that people all of a sudden what they saw that they didn't see before that.
Yeah, because we had GPT-3, which has a lot of the capabilities of ChatGPT. I mean, almost all of them. Like ChatGPT is kind of just like a tuned version of that model. I think it really was kind of the UI changes that being able to have that back and forth conversation. Like when you work with GPT-3, it's just trying to continue whatever you wrote. And so it's not a natural kind of interaction. You have to kind of abstract your thinking and understand what the model is doing in order to work with it. But I think when OpenAI released ChatGPT, I think I recall like Sam Altman saying in some interview or something that they were surprised no one else had done it. And so that's why they did it and then released it. I don't think they expected it to go as big as it did. But that's a much more natural way of like interacting with AI. And then I think a lot of people, there are these moments where like a switch flips in their mind, which is like they can imagine themselves using something for the first time. I think a lot of people, like Uber, for example, I don't know if you remember your first Uber ride, but for me, it was very like weird. I'm like, I'm going to get in a stranger's car and I like see him on this app, like, okay. And then you do it and then you realize like it's not weird and it's natural and it's good. And then it just is a new way of life. And I think that happened with NLP and language models and stuff with ChatGPT. That back and forth conversation opened people's eyes to what's possible. And then they could ask it to do something rather than try to like create a beginning of a prompt that then completes into something that they wanted it to do. and then they realize what the true power of these models are. And then in terms of the vector database part of this, I totally agree with you that it's like Word2Vec was that moment for me when I saw the Word2Vec paper, and then I started playing around with it. Being able to do math with words was just like mind blowing for analogies and things like that. And so, yeah, I think that the vector database piece is it's like the memory of a language model. So how do you get it to use specific information in its generations? And so, yeah, and I think LangChain is also part of this. So LangChain is, for people that haven't played around with it, it's kind of a library of a bunch of scripts for chaining together calls to LLMs and different prompts, and you can change the prompt based on what happened in the previous step. And it's got a lot of attention. It's one of these super hot projects right now. But combining that with the flip switch in people's minds really made vector databases really important on the map, I think, at least in the public mindset right now.
Yeah, I think what might be interesting also, a question for you, Etienne. Of course, I kind of know the answer, but it would be nice for the people that listen to the podcast. So, what was for you the first time that you had this insight from a database perspective, from a vector database perspective, that you were like, oh, wait a second, I'm just not chaining algorithms. There's a bit more to actually building a production system. What was the first time that you were like, oh, wait a second?
Yeah, I think that was, it's hard to say in time, but I know because VC-backed companies always think in like financing phases. And I know that this was around our seed phase, because we had just started experimenting with this, and exactly as Bob said before, like these kind of small paragraphs and seeing does this actually work. And at that time, Weaviate was, because we also came from that direction of knowledge graph, and it was kind of intended as almost like a stateless layer on top of knowledge graphs. And I mean, building something stateless is relatively easy, and that was kind of like what I did before, sort of the whole running 12-factor apps, sort of stateless loads in the cloud, making sure that they scale, which is in hindsight super easy compared to making a database scale. But I know that we were already sort of kind of experimenting with this. Okay, do we really want to become our own database? And I remember that we actually hid that information in some of the first talks that we had with VC companies reaching out, because we're just like, okay, this is too crazy. This is like we're not there yet. We need to first prove that this actually works before we tell others that we're building a database. And yeah, it did work. And I mean, the rest is history. To me, this is to this day something like when I read these tweets like, hey, if you have 100 embeddings, maybe you don't need a database. Maybe you can just run it in memory. Like, for me, there's always like, it's not just about scale. There's so much more. Like, if you want to serve this in production, if you want that to have that be highly available, if you want a backup solution, if you want filters, if you want like all these kind of features that if you want a migration path for people who come from and I think this is also interesting in the context of like LangChain and stuff which brings new users in, but you also have users who already use a search solution. If you want to give them a migration path to sort of more modern search, they're not going to drop all these hundreds of features that they already have. And sort of database, I think, is the wrapper term for everything that's going on here. And making sure that works at scale and at production quality is unfortunately a bit more work than just putting.
Yeah, there's like multiple types of scale too. There's like the scale of your data. So what I recommend is if you have like a less than 100,000 vectors, and you just want to like mess around with stuff on your computer, using like an external database that you're actually like sending data out of your house into their servers and then back in, just to do like little things like that, probably is not the right tool for that job. But if you need to have something that's got, I mean, availability all over the world and needs to have latency under like 10 milliseconds and like production applications, that's a whole different set of needs, right? And then also just so I during my PhD, we created a couple scientific search engines that we serve to the world, actually. One was on COVID literature and one was on material science literature. And the pain of getting that notification at 2 a.m. that something went down and that you have to fix it is just, it's something that still I wake up with nightmares. And the solutions that are hosted or offer kind of more robustness, they really help with that kind of thing. So if you're trying to build like a product that you're going to give to other people, definitely that's something to consider. And then also, I think a lot of people, we're not really, at least in the way that we're having public discussions, like not here, but in general on Twitter and stuff. People are not making the distinction between databases and search engines, and I think that that's actually kind of something that we should be talking about as a community. What are the needs of a database, and what are the needs of a search engine? Maybe we want to get into that here, but
that's actually a very good point, and I wanna add two things to that, right? So we also of course deal with libraries. So we have the and we of course also had Matthijs on the podcast to talk about face and those kind of things. So we have the libraries, the databases, the search engines, and of course embedded also starts to play a role, right? So I think that Dagdelen led the way in that, and that's very interesting because it's a new way of also working at a with data, and vectors play a role in that. So I kind of see these four. These four things. I'm actually curious from both of you to hear the what you think about that. Right? So how you look at these four things, and because I notice I spend a lot of my time talking to people, explaining these four concepts and how they're different. I'm just curious how you guys look at that.
Yeah, you want to start, John?
Oh, sure. Yeah. So I think that the user is one important factor. So like for libraries, the user is kind of a developer, right? Somebody who's trying to achieve a goal, and they don't want to bring everything from maybe they just need a little part of the puzzle. Maybe they want to add a semantic feature to their, like a semantic similarity feature to some analysis that they're running. In that case, you might not want to set up an entire database just to do like calculating similarities between maybe 1,000 things or something like that. And then I think also there's maybe a fifth thing I would add, which would be the data, because what you're actually starting with is so important. That's like the biggest lesson I learned in all of the research I've done, or in this space, at least in scientific language processing. What data you put into this stuff has profound effects on how it performs. So for example, one of our papers in the early days, we trained Word2Vec on a corpus of research papers, and then we used the Word2Vec. It predicts the likelihood that two words are going to appear together in a corpus. And you can actually ask it the probability of words that never co-occur in the original training set. And then you can use that to make predictions about what should co-occur. And we actually discovered a bunch of new materials that way. But if you train the same thing on if you just mix in a bunch of unrelated, like non-material science text, or even material science text that's on a different type of materials domain, the performance just disappears. And so that's a really key piece, especially when you're using semantic similarity and stuff like that. And then, I wouldn't call myself an expert on any of this stuff, to be honest. I use it a lot, but I'm not developing these algorithms I'm not developing vector similarities, approximate nearest neighbor algorithms or anything like that.
But that's actually interesting.
Yeah.
It's interesting to hear it from the perspective of a user who's knowledgeable in the NLP space, right? So that's what makes it, in my opinion, extremely interesting.
Yeah, and if I'm hopping in quickly, I remember that I think it was 2019, that paper you were a part of, that had the unsupervised latent space of material science. And I love that. That was one of the first papers that I saw these clusters of some domain, like scientific literature mining. We also had Kyle Lowe on the Weaviate podcast.
I know Kyle.
Yeah. What's the current state of scientific literature mining, the COVID systems? What are the biggest, what are the frontiers of it?
Yeah, I think what Kyle and the that team did on the core data set was really interesting. I think. So the pandemic accelerated a lot of trends that were sort of already happening. And I think text mining of scientific literature was actually one of those. It was the first time that we had a large scale specific data set of full research papers made available to the research community with no restrictions on how you could use them. That was a really interesting moment, and still a very interesting data set. Because usually the licensing problems with the copyright of research papers can really slow things down. For example, we have a bunch of full text for the work that we do, but we can't share any of it with other researchers. We can't even share the database of abstracts that we use to train our models. So they can use the models that we've trained, but we can't actually just give them the original data that it came from. And so that's one trend that I think as now everybody kind of is just putting stuff on archive first, or even just never putting it in a peer reviewed journal that's copyrighted. That's definitely, I think, a trend that's gonna be important. I think you also see a lot of like search is becoming very important because the quantity of papers coming out and quantity of data, not just in science, but in the world at large. Like people are publishing things in blog posts that would have been research papers a few years ago. And so just having like a good sense of what's out there and how to find it is going to be really important. And one trend that has not caught on yet that I think is actually going to be really big in the near future, at least in science, it hasn't caught on yet, is like these AI assistant kind of ChatGPT style things that allow you to, there's like a lot of common data manipulations that we do, like maybe go through 100 papers and then pull out a specific number that we want to make a plot of so that we can try to analyze a trend. That's going to be the kind of thing that before you had to be somebody like me that like spent years figuring out how to manipulate data, like teach yourself how to code, and then learn these language model technology things, and then put it together into one thing just to make a plot out of that. Or you can give it to what they do is they hire an undergrad intern and then give them this mind-numbing task of pulling these numbers out of papers or something. But probably in a year or two, it's going to be something that you ask like a ChatGPT like a research assistant.
Yeah, I think this is a great transition into a recent research paper of yours on structured information extraction. I love this topic of, just like you mentioned, I remember back when I was wrestling with the Core 19 dataset too. I know Bob has messed with that dataset also, and parsing through the schema. Now the language models can kind of like help with that. Can you tell me about what you're learning about that?
Yeah. So this is something that this was the goal of our projects all along, was to extract research. So I got into machine learning because I started as a computational material scientist. So what we do is we simulate materials on supercomputers at the atomic level. And then instead of doing experiments, you can just kind of calculate what the properties of the material are going to be before it's ever made in a lab. And we were generating a lot of data. We make it available to the world on something called the Materials Project, materialsproject.org if you want to check it out. And that data set size is in the order of like 100,000, maybe 200,000 materials now. And then we have a lot of diverse data for those materials, but it was a lot. So I was like, okay, maybe we can do some machine learning on this. So I started learning ML a bit and trying to train property prediction models and things like that. And then I realized very quickly that we don't have enough data to do the things that like we really dream of doing here. And if you look in just where is the data in the world on scientific knowledge, it exists mostly in the text and tables and figures of research papers. And so that's like how I got into that. And so our original goal was, why don't we just extract the data out and build data sets and then train machine learning models on those? And then what we found is actually the structured information extraction problem wasn't solved yet. And it still is pretty hard. But the new language models are really powerful. And if you fine tune them, you can actually have them extract structured JSON documents that you could then just insert straight into a database, like something like Weaviate. And then get kind of this really powerful mix of structured data. You have the original text from whatever you're extracting from. You can build your own features on top of that. And then that could be the layer that enables these like scientific research assistant models that I was talking about.
Yeah, and I think this is a great, on the vector databases, what do they add? A great angle to it, because once you have these filters, you can do filtered vector search. It's not just like cosine similarities because you have these filters. So this is great. Etienne, could you maybe quickly explain like how does filtered vector search work?
Sure. Filtered, basically, you've explained it right now. You can not just do the similarity search, but you can also set the filter. Okay, sorry. Sort of without going too much into how it works under the hood, the idea is that the vector and the object that the vector belongs to, they're not two separate entities. They're not, and I think this also comes back a bit into like what is the separation between a database and a search engine. Like in Weaviate, we make sure that those live together, they scale together, and they're always together. And why? Because we want you to be able to use those structured properties in combination with your original or with your vector search, basically. So you can kind of combine the best of two worlds, the traditional angle, the filtering. So again, sort of if we're looking at the migration path, if someone comes from the SQL world and says, but I want to set where price equals lower than $20, then they don't want to sort of lose that just because they're, so e-commerce is a nice application, and say they're looking for a beautiful dress to wear in the summer within a certain price range. They're not going to drop that price range just because it's now the NLP part of it is better. But they still want to keep that. And similarly, that also allows for hybrid search, so the BM25 and vector embedding based search, because depending on what the model is trained of, sometimes or not just based on the sort of in domain, out of domain, but also just in general, they're not necessarily meant to match keywords, but sometimes you do need to match keywords in your kind of application, and having that in it, and not just being like a vector being this abstract thing that maybe gives you an ID back, but having the actual object, and it allows you to filter on it, to do keyword matching on it, to aggregate on it. So faceted search, for example, is also for e-commerce is super important, where you return results, and then you want to have these kind of ranges, like it's lowest price, highest price, average price, all these kind of things. And these I call them database features, which is probably not the right term, but it helps to sort of paint the picture of what is it beyond just pure vector search.
Yeah, and I think that like aggregations and things like that are really important, or groups. So you might want to say, let's stick with the science example. So high energy physics papers. If you want to say, what is the average number of authors on a high energy physics paper? That's kind of a difficult task to do manually, and it's even difficult if you have just kind of a traditional table of all those papers, because you need to get a sense of like what is a high energy physics paper within that. Previously you would have trained a supervised machine learning model to make like a binary label for just that label. Then you'd have to go and label that data. Is this a high energy physics paper? No, yes, no, yes, no. Maybe you would use like bag of words features, or like TF-IDF features or something to try to train a model on that. Maybe you could have just done like some manual keywords to look for. But with semantic search, you could just kind of grab a couple high energy physics paper abstracts and say, just give me a bunch of documents that are similar to this, and then give me the average of the numbers of authors or something. And so that's like a really powerful workflow, I think, that these things enable.
Yeah, and to build on top of what you're saying, what you're just saying, John. So it's like, it's not out yet, but when this podcast will be out, it will be out. So because Connor, and maybe in a bit you can say something about it as well, because one thing that we're looking at is what we call these generative feedback loops. And that is something that's very interesting as well. So exactly based on the example that you just gave, John, is you get some information from the database, and put it in the generative LLM, but then you feedback loop that back in and get a vector representation for it. And I think that those kind of things are also very exciting. So, I mean, Connor, you know more about this than I do, but so maybe you can say something about this, but for people who don't know yet what it is, but what that exactly does.
Well, I think I think you did a great job of explaining the whole concept of it, and I think it's kind of like how we open the podcast talking about not like the height necessarily, but things like AutoGPT, LangChain, this kind of like, I think it started academically with the chain of thought reasoning, showing that it could have like a task plan. So there's that's one angle that I like a lot about this save the generations back in the database, because your database is like it's more of like a living entity, maybe like the data ingestion, the continual things it can do with itself sort of, and save its outputs. So, I mean, I think like, and I would love to get your perspective on this with the scientific literature mining example, because I have to give Jerry Liu from Llama Index a shout out, because I've been learning so much of these little things you can do. But I love this like compare contrast documents prompt. So, you upload your new paper about some material, and then it can like sample passages to put into the input to form up this comparison, maybe like automated literature reviews that are kind of like sourced this way, where each comparison is 2 paragraphs, save that back in the database with the cross-reference in Weaviate speak has comparison. So like, that kind of automated analysis of your materials papers.
Yeah, and I think that approach is really interesting because it leverages so I think for people that have worked with language models for a while, you kind of get an intuitive feeling for their strengths and weaknesses. And those are different than I think what people are attributing to them today. So let me give you an example. If you ask a language model to just tell you some facts about stuff, like really well-known facts that appear millions of times in the training set, like the Eiffel Towers in Paris or something, those are going to be in the model's output. But if it's only encountered something like a handful of times or once or twice, it's not going to it's not going to give that fact back to you. And it doesn't make fact-based reasoning decisions that not, at least not in a structured, strong way yet. But it is really good at manipulating content into formats that make sense within the context. And so, like what you're saying, if you give it a couple abstracts and then say, tell me where these abstracts agree and disagree, those models will be very good at that kind of thing. That's just their like really strong suit. And so I think that you can get around the hallucination problems and some of these weak areas of LLMs right now by leveraging kind of what the community has been building. And like when ChatGPT came out, ChatGPT is sort of a GPT-3, a little fine-tuned for how it should output answers, but combined with essentially like a vector database, right? Where it's like looking up past messages that it sent and you sent to give you better context when it needs it, or to get better context when it needs it. Like, in fact, when I saw ChatGPT and I got first access to it, I DM'd my friend Joe Burgum, who's he's the head of Vespa AI, which is like Yahoo's vector database. I'm sure you guys are familiar with Joe.
Of course.
I'm like,
hi, Joe.
Yeah.
Yeah. Thanks for watching, by the way.
But I DM'd them. I said, hey, I think if we just connect an LLM up to a Vespa DB, like, I think that just creates a ChatGPT kind of experience. And yeah, it just this explosion of thoughts happened in my mind when I started seeing like all the possibilities here with the fact that people wanted to use them, right? And I think that's another thing. Like the user, maybe there's a sixth element to that thing, which is the user. You know, what are they trying to accomplish? And I think people's imaginations have been expanded recently in what they think they can do.
Exactly. And that's also something, so that's where the like how this whole conversation started, right? That question that I was curious what you thought that happened. And I think exactly what you just said, that's the thing, right? We see that with Weaviate as well, that people are like, oh, wait a second. So now I can basically have my own data, whatever that means, or whatever that is, right? We can inject that and then get these results out. Funnily enough, I always use the Eiffel Tower is in Paris as an example, because one of the things that also been experimenting with is like if you just basically for lack of better terminology, if you overwrite the knowledge that the model has with prompt injection. So the example that I often use is if you have something like the Eiffel Tower was in Paris, but it's moved by truck to Barcelona. And then basically, if you now have the question, where's the Eiffel Tower? And from the vector database, you can get out the that document that says something that the Eiffel Tower is moved. And you can use it as a prompt injection. And you can basically, in your prompt say, okay, you must base your answer on the following information we're giving you. And I think that is very exciting, because then basically you're trying to use the model more for its language understanding rather than the knowledge that it has. So I have another question, because a lot is dominated, for obvious logical reasons, a lot of is dominated in discussion by language models. And we kind of can also see with like multi-model models and image models, those kind of things. I'm curious, because you've also been working in other fields, John. What do you think? What different types of models, or what kind of different types of embeddings will we see, in your opinion, that are not language models, that are not image models? Will we see other things for, I don't know, anything that can come to mind?
Yeah, I think that there's so I think at some point we're going to have, it's beyond like an image model I think that this is what some of the AI, like the quieter AI startups are doing, like the big ones, which is you're going to be able to have like structured embeddings or latent representations of like a user's intent using something. So like what was the sequence of things that they just did on their computer that will like inform what they want to do next. And like I think it's not hard to imagine a near future where it's just embedded in the operating system of the computer you're using. And it just like it notice that you want to do something and it'll just do it for you, or like suggest, hey, it looks like you are, you have a PDF open. Do you want me to just summarize it for you real quick? Instead of you having to like write a prompt that says summarize this document or something like that. I think there's also a lot of opportunities in like multimodal, but understanding like how information is spatially laid out, not just like an image embedding, but like let's imagine we all see lots of PowerPoints probably. PowerPoint slides are laid out there's like semantic meaning in where stuff is and what size it is and what color it is and what images go along with it, beyond just like a single embedding, right? There may be like contextual understanding there, like what was the previous slide, what was the train of thought that this has been going on through here. So there's like right now we're just scratching the surface with how we represent information. There's so many deep levels that we could get into. So that's actually where I'm interested in going in my near future is especially this kind of these like deeper ways of thinking about how do we represent information, how do we leverage that to do useful stuff.
Very interesting. How do you think that embeddings is for the coming years, that's the way to go, or do you foresee something new, something different?
I think we're going to see a lot of. I think you guys have experimented with this a bit, which is like the query expansion stuff using these models, where you can basically like if you tell an LLM, hey, there's like more ways you can interact with a search experience to get information you're interested in. Like you can tell them about the different fields that are in your DB and like what possibilities there are in there. Especially if you can then like fine tune it just a little bit to like work better with your database. I think really interesting stuff is going to come out of that. I think multi-vector stuff is really interesting to me. So you have like multiple documents. You might have like an embedding for each sentence within a paragraph. So like you might do one embedding search to find the right paragraph and then another one to find the right sentence and then use that as evidence for something. How do we so like right now embeddings, when you just do a query embedding lookup, they're just doing a cosine similarity or some sort of nearest neighbor similarity search for things that like seem to align together. But that's not like the optimal. I mean, like a query looks different than a document, right? Like the questions, where is the Eiffel Tower? Maybe a document says the Eiffel Tower isn't where, that might be similar. But like another document might say like, where is the Eiffel Tower's builder's grave or something? And then that might like also be similar because it has where is Eiffel Tower and stuff in it. Especially if your embeddings aren't like from a really deep model. And so I think that's one problem is that query answer alignment thing that might be like solved soon, where you have another model that is just repositioning the query vectors into the document space in a better way. You may also want to do things like contextual embedding of like, there might be like fast embed where you take embeddings as they are, and then you remorph those based on the context that you're looking for. So like you might have a bunch of documents, but you really only care about like one aspect of that space that you're searching in. So if you have a bunch of like fashion descriptions of like fashion items, if someone is really just looking for like material based stuff, like what material are they made out of, like they don't care about like the cut of the thing, you might do like if that isn't like an explicit column in your database, you might not be able to do a lookup on that with like semantic search. But probably there's a way with ML that you could realign those two things just to redistribute them based on more material information rather than like the overall information of the thing. Yeah, things like those I think are really interesting areas that this is all going to go into.
Yeah, it's super interesting. I have the same thing with the interfaces, right? So for example, what you now see with these models, and then for example, translate something to SQL, or for that matter, a Weaviate query, those kind of things, that I would not be surprised that we're going to see innovation where that just goes away. That we just literally directly go from natural language to a form of doing a lookup in the database.
However,
I don't know how that will work yet, but I those kind of things I think we'll see as well. And I have one more question that I'm very curious to get your thoughts on, John. So one of the things that this kind of related to how we started the podcast, right, and how everything is like now that everything is growing very fast and rapidly, and I think it would be fair to say that a certain type of hype is happening. One of the things that I always say is that I think that so the term that we've adopted to somehow share that with the outside world to make sure where we believe where things are going is like we've adopted this term AI native. And one of the things I always say that I believe is that it's very exciting of all the things that you can do now purely with the models, right? So, and people will build new products, people will build new startups. But what I actually believe is that in the not too distant future, it will just be sprinkled in everything, right? So you gave the example of of doing something on your laptop that you might open like PowerPoint, and you get some suggestion or something is happening where these models in combination with these embeddings and these databases play a role. Do you think that's a fair assessment of how you see things developing, or would I be stretching it when I say that?
Yeah, so I'm not the deepest expert on all this. Like there are probably people out there that have an even better view into where things are going, but I think definitely that's going to be the future we live in, where like AI is going to be it's just going to be like part of everything, because the way the mental model I use for this is that there's like this set of problems that we know how to answer with a step-by-step solution, that we know all the steps. So like that's just code, right? So I know how to display a button on something that is rendered by a browser so that when your user clicks it does something. Like that is something I can like break down into step-by-step solution. But I would not be able to write a piece of step-by-step code to do image classification, for example, of like what is a dog and what is a cat. That'd be like incredibly hard to do, almost impossible. But the beauty of machine learning is that it lets us create programs like that we can run on computers that do things that we don't know how to write this explicit step-by-step solution for. Just by showing it enough data of the examples of what we want, it'll do it. And so before, you imagine like we had like only this part of the world that we could build in because we knew how to write code for it. But now like the rest of the world that we didn't know how to write code for before is available to us. And so I think that's actually where a huge number of problems that people run into, or like human desires and like the problems we want to solve, required that higher level of thinking or kind of ways we didn't know how to write code to solve it. I think that's going to be the story of the next like 25 years.
Yeah, I have one more thing on that, John. Do you like? I love this kind of step by step where we could easily define a task. Now the task is more abstract, and I think the next step on that is the tasks that we don't even know are tasks already. And
that's really interesting.
I think the answer to that is this open-endedness stuff. Like from like I remember like Jeff Kloon and Kenneth Stanley had done a lot of this. They have this like the initial experiment was this thing called Poet, where it was like a bipedal walking agent and all sorts of environments for it to walk in. And now they are testing this in Minecraft simulations. So I think with the large language models and how we're simulating them, like you could have like a little economy where they each have roles, and you can simulate this and create these like open-ended worlds. So do you like this idea of open-endedness?
Yeah, that sounds awesome. I think that's especially going to be interesting. So I don't play a ton of video games anymore. I don't have a lot of time that I spend doing that, but I still think about them a lot for some reason. And I think that like it's just kind of this idea of this like holodeck that you can just go into and experience a different world that has its own like story and life going on and its own things. Like that is an enticing idea to me, that we could do that in a more serious way too, not just for entertainment, but for, understanding economics, or like even, how if we build this city this way, like let's say we're going to redevelop a certain area, what would the impact on people be? Like, would it have any weird externalities that we're not anticipating right now? Like maybe you could simulate that with some agents in a long and figure out like in the next 50 years, how's this area going to look? Things like that.
But not only that, so the podcast that Connor and I recorded about these generative feedback loops, that were we talk about like what can this lead to, right? So and one example that I often give is like in the form of newspapers. So that we could say like you can get to a situation where you might be reading a newspaper that just shows a completely different article, like as in the text in the article based on my preferences and my knowledge, as opposed to what is shown to somebody else. So if there might be an article about specifically highlighting something about, maybe machine learning, then for John, for you, it might show more detail, or Etienne for you, and for me, it might be, more holistic view or, tailored to my interest. But I could imagine that we're going to see platforms, and I would also not be surprised if that starts with, for example, newspapers or maybe music or movies, those kind of things, where, and then building on what you just also said, Connor, is the that just is completely different at some point for everybody else. That is not even like a article that is different, but just that you just get your completely own space in the news realm, for example, or in entertainment or those kind of things, where you just see things that are tailor-made to you, and where there might even be agents that help you navigate to that world that is tailor-made for you. So I can definitely I can definitely see that. I can also see the scaling issues that might come with that, agent. But that's
I love the idea of dynamically adjusting the not just the content but also the modality. Like if you maybe prefer reading a long article or you prefer watching a short video or something like that, there's like so many different ways to consume anything really. And I guess right now you just have to sort of either you pick the largest user group and you produce it for that particular group, or you produce multiple things. But the idea of just having the content just be there just once and have the user on the fly turn this into a video or a text or a blog post or a scientific article, that sounds really enticing as well.
Yeah, like I could imagine a future where I'm watching a video at home and then I need to drive somewhere, and so like it seamlessly transitions into an audio only version of it, but like expands the description of stuff so that you don't need to see the visuals. And then maybe I get out of my car and I go into a coffee shop and it swaps to like a text version that is easily readable on my phone, like so that the information is consistent between all of those versions, but the like actual delivery mechanism has changed. I think also, so like this idea of everything is going to be custom tuned to us. There's also this really interesting alternative like thing that will probably happen in parallel, which is like why do we consume art right now? It's like movies or something. Like I'd like to use Wes Anderson as a good example. Like his movies are so different from other movies and like from what we would have created ourselves in our own imaginations, like those images and the colors and stuff. That like we kind of, it's delightful to like live in someone else's mind for a little bit. Like that's kind of just interesting to humans, I think, to people. And I think that like the power of these generative models is going to be that like you can have art people with like, you could go see someone else's hyper tuned version of the world, and that would be probably extremely interesting and stimulating for people. And so we're all going to be able to be our own like Wes Anderson. Like we'll have beautiful, amazing stuff that we could share with others so they can kind of visit us in our worlds and stuff. I think we're going to see just a lot of really good art coming out in the next, just interactive art, things like that.
Yeah. And it's nice. So also something purely by coincidence that we discussed yesterday, also with Connor, is that you often see there's this author I really like, Bruce Sterling, who writes about these ideas, about these concepts, and then he says like, if you want to see these innovations, then look at music. There's like often it's first happens somewhere, somebody does something with music, so it can be generative music or those kind of things, and then it slowly trickles into other art forms, and then it trickles into business, and so it's exciting to see what will happen. But I can see this. This is just I can just see this happen. It's like not very hard to imagine. So thanks for sharing. This was great.
Sorry. I think so much about that. Because I think a lot about Weaviate. We have ref to vec, which is our approach to personalized embedding, where it's like we use the graph structure with users and products. And I love what you're saying. Like if the four of us were to watch a movie together, we can maybe average our 4 embeddings and then search with that vector. So But anyways, yeah.
Exactly. It's super exciting.
Yeah, and Bob, you first, I remember you pitched the idea with Marco and Chris of like an embedding that you take everywhere, like your digital kind of embedding that you take all over the internet. And I thought that idea was so cool.
Yeah, exactly. And that's a little bit complex in the sense of then that somehow needs to be aligned with other with all the other models. But the point of that was more like a representation that you. So the example that I gave is that would be nice if you would have a representation, so that if I, to stay in the realm of art, that if I go to Netflix, right, that I present it with my embedding or my identity, and if I go to Disney Plus, that I again present it with my embedding or plural embedding, whatever. But conceptually, that's the idea, right? So, and that you can basically say, okay, this is what I'm interested in, and then that it generates stuff for you. I can see that happening. We talked about, you mentioned Wes Anderson the other day. Somebody made this video, I saw it on Twitter, with like this generative Star Wars movie in the style of Wes Anderson. And I think what's very interesting, now somebody made that, right? So somebody was rendering these frames, and then, probably somewhere in Final Cut just, got these things together. That is just work that can be automated, right? So the time that you're watching a show on Netflix, and that says like, hey, in 15 minutes from now, your next show will be rendered for you based on that's so going to happen. That's just, I bet a nice bottle of wine on that's going to happen in the not too distant future. Yeah.
Yeah. I like this idea of having this embedding you can bring with you that kind of describes who you are and like what you enjoy and what you're looking for. It's sort of like, it'd be really cool if you could decouple it from like ad targeting in a way. Like, it's not what age am I and, what part of my life am I in? Like, I'm looking for more, this is what I'm interested in seeing right now. Like, being able to provide that to recommendation systems, no matter where you go on the web, have like a universal system that you could just give them permission to use your personal vector or your personal embeddings. Because for example, like I like certain types of restaurants, like atmosphere to me is really important. Like, how does the restaurant feel architecturally inside? And like being able to go to a new city and then just pop that into the search and be able to like have it recommend places specifically for me in the context of that city. That'd be cool.
Yeah, I think the example that I gave on that podcast, if I remember correctly, is a car, right? So let's say that you rent a car, and what you already see now with a Tesla, that you can adjust it for like how you like to drive, when it drives for you, those kind of things. That you just rent a car, you go in the car, and the car just, okay, this is the type of driver Bob is and what he's interested in. And hey, maybe he had like a busy day, so let's just, relax a bit more, whatever the thing does, right? But I think that's an example of where such an embedding does not have to have specific information like my age or those kind of things, but that it just knows what type of driver that I am. So it's like but I always like to do those, like I like to decouple these things in the brainstorm process. So basically, we're now in this realm of brainstorming about the opportunities, and I always like to decouple the risk from it, because sometimes what happens with these creative processes when thinking about these kind of things, if you then try to reserve a little bit in your mind for like, okay, this might be a problem, then you hit a roadblock in your thinking. So I always like to go through the whole process of thinking about it and then going end to end. And it's like these speculative design kind of methods. But it's okay, now we're like end to end in the opportunity. Let's write them down or those kind of things, and then let's revisit what potential risks might be or something. But that's just more a practical thing. But I like to think about these kind of things and to share this with the world, because that's really nice. And I love what this podcast turned into, because I think more and more people are getting inspired by these ideas. They're like, hey, I'm working in whatever they're doing, right? And I can align this idea with what I'm trying to build. So that's exciting. That's very cool. Thank you.
I've very recently had an exact example of this sort of personalized embedding approach. My Spotify contract was tied to my phone contract, which I had no idea. But when I switched my phone contract, all of a sudden I had no more Spotify subscription. So I thought, like, okay, already pay for YouTube Premium, so why not give YouTube Music a shot? And it was interesting for the first time in I don't know how many years to retrain basically an algorithm, recommendation algorithm, to retrain it like, what music do I like? And it's kind of like, on the one hand, I wish that I could have just taken my Spotify embedding, so to speak, and just put it into YouTube Music, which kind of like opens up that question of who should own what data. Like, if is recommendation data that's kind of specific to you as a user? Like, should you have like a request where you can just download this and personalize it? But at the same time, it was also an opportunity to really think about like, what music do I listen to because Spotify recommends it to me, as opposed to because I actually want it. So like, how do I want to influence this retraining? So not just have your personalized embedding, but also think about how it evolves and how you maybe want to change it.
Yeah, I think that's really, and that sparks a lot of ideas for me too, because I use YouTube more than I don't watch TV. I just watch YouTube for the most part. I have it on my Apple TV on my and it gets hooked on these like it shows you nothing but gardening videos for like weeks, and you're like, stop showing me gardening videos. I don't want to watch these anymore. Like, you watch one video and it just like, like the recommendation system thinks, oh, now this is all you want to see. But it'd be really nice to have like more trainability into these things, or be able to just write out like what you want, like, hey, stop, and then have it adjust the ranking algorithm to give you, something that's more aligned with what you want.
Yeah, it's fascinating. It's interesting. I noticed that I recently was using it was like one of these speakers that you can buy, and they have like their own apps, but they were connected to the Spotify API, but they didn't have the suggestions and the ranking of Spotify itself. And then you notice already how good it is inside if you're in Spotify. Because I tried to find an album and I just couldn't. And I knew that it was just that this other app that was connected to the Spotify API, just had like very basic keyword matching. And if you try to find an album that has like, I don't even remember what I was trying to find, but I found some pretty weird albums with the same words in there. So it's like, but it's a good point. And that next generation of really using language to just describe that. But I think also conceptually that we just need to go to a situation where you're telling YouTube something, like we're now talking to each other. It's like, hey, YouTube, appreciate the gardening videos, but I kind of had it. My garden is done, right? So I want to see something else.
Yeah, exactly. Yeah.
I think I remember the first time that I put something in that I made a prompt, that I wrote a prompt, and that something sensible came out. That I remember like, whoa, I need to get used to this paradigm shift of writing a prompt and not doing something in a certain structure. I really, really, really needed to get used to that. So, but I think so even my point is, even if these platforms get to the point where they accept that and they can actually properly do that, just changing people's behavior, that they start to interact with these machines in a way that is like basically another person. I find it fascinating. There's actually I think it's like a paper, maybe it's like a psychology paper or something, but it's like that somebody published about the question that if you interact with these machines, if you should say please. There was like a whole thing that they were, and then it was like related to children, right? So if you, for example, if you ask something from another human being, you would say please. But should you teach your children to also, politely ask the machine to do something for you? It's interesting. It's exciting stuff that's happening.
Well, who of you have used please before in ChatGPT? I'm definitely guilty of that.
I'm not decided on whether I think even AI. I think definitely not at this level is AI like actually conscious. But some people I respect their opinions on things. They're like, yeah, maybe we should have a more open mind about what consciousness means. And I'm like, okay, well, it doesn't hurt to be polite at least. Like, if some super race of aliens out there comes into Earth and they're like 10,000 times more smarter than us, if they said please to me, I would be like, okay, that'd be nice.
Great. Yeah. Thank you.
I think about if saying thank you would be worth the extra request to the API, though.
Oh yeah. Well, it's only
pay by token.
2 tokens. Yeah. So like, it's a fraction of a cent. But, so I think actually we could get to this kind of instruction fine tuning database lookups sort of, or I don't know what to call it. That's a bad way of putting it. But like being able to create a model that you just say, hey, can you downrank gardening videos for me? Or like say it in a more natural human way. And then it would translate that to things that could go into the call to the search backend that like downranks things with certain keywords. Like it might know how to make the database do what you're asking it to do. Like maybe this is something that you guys could pursue. Being able to just take a user's like contextual prompt in and then translate that to database, query features that make the search more relevant to what they're actually looking for beyond just the query.
Yeah. And that's a very interesting point, and brings something else to mind. Is that something that is super exciting also for me to see? Is that what's kind of new in infrastructure is that, or databases specifically, is no models, no vector database, right? So it's like they go hand in hand, and the people that are building these models and that work on these models, we're working with a lot of them. And just as you just did, John, and we're getting suggestions, and it's like, how can we do that from the perspective of the database, and how can we, and then what's the where does the database start, where does it end, basically those kind of things, and also with the models. I think that is something that I'm super excited about, because it just basically means more people working together on solving these problems. And in the end, yes, it's exciting, but it's also just people working together, right? So that's that's something I'm maybe even the most excited about. So that's cool. Yeah.
And then we could like imagine a future where there is no distinction between your database and the model, and it's just one thing, like that you say, here's a document, insert it, and it does. And then you say, hey, give me documents that match this kind of query profile, and then it just pulls them out. Or you could mix in like, you have images and documents and audio, and it's just all just like a blob, but it's an intelligent blob that knows what's in it and knows how that stuff relates to each other. Like you won't even have to explicitly create indices yourself. Like it'll just do that based on the data that's in it.
That's actually why I'm the term vector database, right? So the term vector is, and I get it. I understand why it grew into being called like that, and why we call it that. But actually, I hope that in the not too distant future, our users don't even have to worry about the fact that it's an embedding that's being stored. So the example that I often give is, if you use a traditional search engine, do you know what kind of indexes touch when you search for something? Most users don't. So, and I hope that we get there. That we get there as well. That's also why I think it's important that the accessibility to the models, but also to the database, so that you move as much to a natural language as possible. That's important, because that just gives a lot of people access to use these technologies in their stack, rather than complicating it with that kind of language, and the people need to learn what embedding is and those kind of things. So it's so long story short, I agree with you, John. I hope that at some point this just becomes like one big blob of stuff that people can just, I want to use this for my next project or whatever, and that they just embed it, regardless if that's like in the cloud, on their laptops, in their phones, in their cars. I don't really care what it is, but that's the I really hope that will be that will happen sooner than later.
I think to some degree we almost already have that, if you, depending on who you define as the user. Because for us, from our perspective, it's typically the one, the database operator, or the one that would spin up Weaviate. But the end user that just sees a search interface, what are the odds that they know that there's a vector search going on? Like if you use Google right now, how much do you know about what's going on under the hood? So, and I think as more and more vector and similar search solution make it into production, that also means that more and more end users are experiencing basically the benefits of vector search without even knowing that it's there.
Yeah, I like this like abstraction concept from computer science, where you just kind of handle something and then that's no longer a consideration you need to make, and you can think of it as a different thing, like a key value store. You're not thinking about how like the data is being like laid out in memory and stuff. You just think of it as, I put a key and I get a value out. And I think like we're going to keep abstracting stuff higher levels, so that right now the abstraction level that like software engineers think about vector databases, like I need to embed vectors and put them into a certain place, and then I need to do lookups, like whatever. But I think like at a certain point we're just going to have this again, like the abstraction layer is going to increase, and it's just going to be like a thing you can put things into and get things out, and you're not going to think about anything about how it's actually works on the inside. And then what's possible, right? So like now you don't need to think about those things in order to build an app. And who's going to be able to, like, we're going to be able to think at higher and higher levels, which is really, I think that's where like really interesting things come out. And you kind of see that starting to happen with the LLM community. Like they sort of treat the vector database that they're using, or maybe a HyperDB, like NumPy array, cosine lookup thing. But they treat whatever that is, like they don't actually care how it's implemented. And that's why sort of they'll just pip install something and then use it, even if it's sending their vectors out to a third party like server just to do search on 10 documents or something, because they just want to think at the higher level of I'm instructing an AI to do something and it needs to be able to like have some data and look it up. And so this is kind of like the trend we're going into.
Yeah. Exciting. I mean, it exactly. And that's like, I think this is going to go for like at least the coming, what you said, 25 years, probably that's gonna happen. So thank you for sharing this. It's super exciting. Also, what you're working on, because we besides of course HyperDB, we didn't know what the other things were that you were working on in depth. So that's nice. Thank you for sharing.
Yeah, thanks for having me on. I really enjoyed talking to you.
Yeah,
thanks so much.
Thank you.
Thank you so much, John. Super exciting.
Thank you so much to John Dagdelen for joining the Weaviate Podcast to talk about HyperDB and all of his super exciting work on scientific literature mining and material science. Please follow John Dagdelen on Twitter at JMDagdelen. Thanks again, John.